Welcome back, guys. Let's move on to page 3, Unit 1, page 3 of our guided notes. Okay. So we're going to look at this equation, then we're going to talk about scientific notation, and then we'll finish up our time looking at some graphs. Right? So here's the equation. The pressure in a surface is equal to the force divided by the area, and that's what that was the sentence or word form of this equation. Pressure is going to equal force divided by the area in which it's applied. A 53 kilogram student exerts a force, and that's their weight, that force is their weight, of 520 newtons. If the pressure exerted on the floor is 32,500 newtons per meter squared, what is the area of the soles of her shoes? Okay, so we're going to list our knowns. We know that the mass of the student is 53 kilograms, and we know the force being applied is 520 newtons, and we know that the pressure is 32,500 newtons per meter squared. What's our unknown? What is the area of the soles of her shoes? So we want to know the area. Okay. So now that we've listed our knowns and we recognize our unknown, we need to realize which equation we're going to use, and it's probably going to be this one that's given to us. That pressure is equal to force divided by area. And notice we have our unknowns and every other value we have, and this was unneeded information. It was just extra information. You're going to run into that a lot. It's kind of like distractors, right? So we don't, in fact, need that. Okay, so now we're on to our second step, solving for the unknown. So let's rearrange the equation so we can solve for the unknown. Now pay close attention, because this is a mistake I see very often. It's really simple. Okay? We're solving for the unknown value of A. And what I see happening all the time is students divide both sides by F, and what they don't realize, if I divide this by F, so now I have pressure over force, that doesn't equal A, that equals 1 over A. Okay? And so we're not solving for 1 over A, we're solving for A. So here's how I go about working through this problem so that I don't make that simple mistake. First, if my unknown is in the denominator, it's on the bottom of my fraction, I'm going to multiply it so that it's on the top of my fraction. So I'm going to multiply both sides by A. And so that would give us area times by pressure is going to equal the force. Now that everything is on the top of the fraction, we're going to divide by the pressure to get the area by itself. So area is equal to force divided by the pressure. See, it's the inverse of this. And that would make sense because that is equal to 1 over A. Now we're going to make sure our units show us that we did this algebraic expression correctly. All right, let's solve for our unknown. So our force is 520 newtons. Our pressure is 32,500 newtons per meter squared. Okay, so run that through your calculator and see what your final value is. I'm getting 0.016. But what's my units? So let's look at that. We're taking newtons and we're dividing by newtons meters squared. We have a fraction, so let's put the other value over 1. So we're dealing with 2 fractions instead of 1. Dividing by a fraction is the same as multiplying by the reciprocal. So this would be newtons over 1 multiplied by meters squared per newton. Now those newton units cancel, and I'm left with meters squared over 1, which is the same thing as meters squared. And is that an area? Well, it is. That makes sense because I'm taking a distance times by a distance, length times by width, and that gives us an area. Okay, so we evaluated it and we confirmed that that answer makes sense. All right, on to scientific notation. Okay, so to use scientific notation, your coefficient has to be a value between 1 and 10. Okay, so our coefficient needs to be a value between 1 and 10, and then you're going to have times 10 to the power of something. So make a little change in your notes. A number, the coefficient, must be between 1 and 10, and it must be multiplied by 10 and raised to a power. Okay, so it's multiplied by 10, and that is raised to some power. So we have our exponent is that raised to a power. Okay. We're going to rank the following numbers in scientific notation from largest to smallest, and if they're in standard notation, we're going to make that change first. We're going to convert them first. So we got scientific notation, and then standard. Okay. So let's convert this. Here's where my decimal place is. So let's move the decimal so that we have a value between 1 and 10. And when I look at this, everything else, they're using 1. So instead of using the 10 value at the end, I'm going to use a 1 value. So I'm going to move this decimal 1, 2, 3, 4 places. Okay, 4 places. So I have 1.0 times by 10 to the 4th, but how do I know if this 4 is positive or negative? Here's how I like to remember. If my coefficient is becoming larger, then you're going to have a positive exponent. Okay, so again, if this coefficient is becoming a bigger number, then we have a positive exponent. Okay? So when we look at this, we see times 10 to the 6, and so that 1 is going to become a very big number. Now we have 10 to the negative 4. So let's look at this and we'll come back to it. I'm going to move my decimal 1, 2, 3 places. Okay? Moved it 3 places. So now I have 1.0 times by 10 to the 3rd. But is this positive 3 or negative 3? Well, my coefficient is becoming a smaller number, and so we're going to make it a negative sign. Okay? So again, if the coefficient is going to become small, then we're going to have a negative exponent there. All right, now let's compare. So we have large number, 6 compared to 4, so there's our largest. Okay, so we're going to put this in first place because it said to rank them from largest to smallest. And then I'm still going to clarify. I'm going to say that that's the largest. Okay, and then the second largest is there. Okay, now we have negative 4 and negative 3. Our negative 4 is going to be smaller than our negative 3. So this is going to be 3rd place. This is going to be 4th. And that's the smallest. All right. Now, you're going to be dealing a lot with scientific notation where you're multiplying them together and you're dividing them. So here's a trick that you may want to add to your notes. If you are multiplying 2 numbers in scientific notation, you're going to multiply the coefficients and you're going to add the exponents. Okay, so if I look at 1.5 times by 10 to the 3rd and I look at 3.89 times by 10 to the negative 7 and I'm multiplying those values, first I'm going to multiply 1.5 times by 3.89. Okay, and that gives you 5.835. Okay, times by 10, well, times by 10 to the what? So we're going to take 3 and we're going to add that to our -7. So a +3 plus a -7 is going to give us a -4 value. Okay, so there's the top of the fraction. Now we're going to look at the bottom of the fraction. We're going to take 9.7 times by 10 to the -9, multiply that by 4.5 times by 10 to the 6. Multiplying scientific notation. So multiply the coefficients, add the exponents. So 9.7 times by 4.5, I'm getting 43.65. Okay, times by 10, so we're going to add these together. -9 plus a +6 is going to give us our -3 exponent. So now we have two numbers in scientific notation, and we're dividing them. And the way that you do this is similar. You're going to divide your coefficients, and then you're going to minus your exponents. So 5.835 divided by 43.65, that gives us 0.133677, etc. Okay, so we'll end it there. Okay. Times by 10, and then -4 minus the -3. -4 minus a -3. Okay, that would leave us with a -1. So 10 to the -1. But our last step here is this is not in standard form because our coefficient here is less than 1, and it needs to be between 1 and 10. Okay? So if I move my decimal to the right, I'm going to have 1.337 times by 10, and I made this number smaller by 1 space, so I'd have a -1, and I'm going to add that to our existing -1. So we're going to have a -2 value. All right, last part of this, graphing. Okay,